Hello everyone, I'm Xingyuan Bu from SenseTime. Today I'm going to introduce our paper called Large-Scale Object Detection in the World from Imbalanced Multilabels. From the history of deep learning, we know that the development of an area is closely related to data. The recently published large-scale OpenImage dataset, which contains 1.7 million images with 500 categories, unseals the limits of data-hungry methods and may stimulate research to bring object detection to more general and sophisticated situations. Restricted by labeling cost and limitation of human annotator, such large-scale datasets usually suffer from several major problems. Objects may explicitly or implicitly have multi-labels. As objects in physical world always contain rich categorical attributes in different levels, it is likely some objects hold both parent and leaf labels, like fruit and apple. Meanwhile, objects could easily have multiple leaf labels. For instance, a car toy is labeled as toy and as car. Concurrent relation between two categories can be obtained by computing the times when two categories appear in the same location of one image. Finally, the open image is collected in the world, including infrequent and very frequent categories. The most frequent category owns more than 30,000 times the training image than the most infrequent categories. To resolve the multi-label problem, we propose a novel loss called Concurrent softmax. As one of the most widely used loss functions, the original softmax is presented here. Assume that we force assign all the M multi-label. The I is optimized in the wrong direction when I is a positive label and M sigma I is greater than 1. Here we modify the original softmax to address the multi-label problem. The 1 minus yi removes the suppression effect between explicitly multi-label categories, and with the 1 minus rig, suppression effects between confusing pair are weakened. For imbalanced label distribution, the non-balanced sampling may cause insufficient training for those infrequent categories. Also, the naive class-aware balance, which samples categories uniformly, is still hard to cope with extreme imbalanced data, and may have two consequences. First, for frequent categories, they will not be trained enough because part of their image have never been seen, therefore wasted. Second, for infrequent categories, the intense oversampling may cause severe overfitting. To harmonize the frequent and infrequent categories, we introduce a soft balance by adjusting the balance factor lambda to leverage the non-balance plus class-aware balance. Besides, we propose a hybrid training scheduler in which the detector is first trained with the conventional strategy and then fine-tuned with soft balance. This hybrid training scheduler explores the effectiveness of pre-trained model from OpenImage itself instead of ImageNet. Here we explore the influence of concurrent softmax in training and testing stage respectively. As you see, our concurrent softmax outperforms the BCE, co-BCE, and distribution CE, and we found applying concurrent softmax without training can bring 0.32 MAP improvement. It also proves that the suppression effect between concurrent categories is harmful. The class-aware sampling boosts the non-balance to 55.45 MAP. On top of it, our soft balance yields an improvement of 1.59. The figure shows that the most frequent and the most infrequent categories are increased simultaneously. Finally, by using hybrid training scheduler, other tricks and model ensemble will achieve 67.17 in the leaderboard, which is 4.29 higher than last year's best result. Thanks for your audience.